YouTube. Okay, let's talk about Chapter 11 test review. The first section, name the angle pair relationship and find the measure of angle B. How many answers should you have on this page for each one? You should have 2 for each problem, okay? I want the angle pair relationship and I want the angle measure, okay? So, how many angle pair relationships are there?
4.
There is 8. How many questions are there on this page? 8. So when you use an angle pair relationship, you're not going to use it again. It's kind of like matching. Okay? But you have to remember them. I won't give them to you. So on number 1, I have 2 parallel lines and a transversal. So draw your box. Are they inside or outside? Outside. What's the word for outside? Exterior. Okay, what's the other part we have to figure out? Right. Draw your transversal line. Are they on the same side of that line or opposite sides? So what is opposite? Alternate. Yep. So I have my angle pair relationship. What else do I need to figure out? The measure, right? This is one answer I need. I need my second answer. What do I know about alternate interior angles? They're the same. They're congruent. Okay? If you couldn't remember that, okay, look at this. This angle is acute. Does this one also look acute? Yes. Okay, so you know that they're going to be the same. So am I done on number 1? Yes, I have my 2 answers. Since I used alternate exterior, am I going to use it again? No. Okay, let's look at number 2. What is this angle pair relationship? Why is it supplementary? You're correct. What's a dead giveaway for supplementary? What do you look for? The line, a straight line. Okay, we have a straight line, so we know it's supplementary. Now what do I need to find? The measure. What number goes with supplementary? 180. How can I find that missing angle? 180 minus 101, which is 79. So I got my 2 answers that I need. Okay, I use supplementary. Can I use it again? No. Okay, number 3. 2 parallel lines and a transversal. Draw your box. Inside, outside, or both? Both. So what's the only option if it's both? Corresponding. Okay. Do they look the same? Yes. So if one's 30, the other is 30. I use corresponding. Can I use it again? Nope. Are you seeing the pattern? All right. Number 4, I have 2 parallel lines and a transversal. What should I draw to help me? The box, yep. Inside or outside or both? Inside. What's the word for inside? Interior. Now I need to figure out, are they on the same side or opposite side? Opposite, so that's alternate. Okay, I have my angle pair relationship. Now I need to find the actual angle measure. What is it? Do they look the same? Yep. So if one's 41, the other is 41. Okay, can I use alternate interior again? Nope. All right, number 5. Dead giveaway. The box. What's that angle pair called? Complementary. Which complementary, what number goes with complementary? 90. Okay, complementary goes with 90. How can I find that missing angle measure? Subtract from 90. 90 minus 32 is 58. So I have my 2 answers. Can I use complementary again? No. Okay, number 6. What do we think? It is vertical. Why is it vertical? It's across from the intersection. Good. What do you know about vertical angles? They're congruent. They're the same. Good. Can I use vertical again? Nope. 2 more. Number 7. Draw your box. Inside, outside, or both? Inside. Now, same side or opposite sides? Can I abbreviate this one? Yep, SSI. What do I know about SSI angles? What? So if you were questioning it, this one looks acute, right? This one is acute. Does this one look acute? No, that one looks bigger than 90, so what do they add up to? 180. So I'm going to take 180 minus 37 to get 143. Okay? All right, we got one more. What's the only angle pair relationship we haven't talked about? Adjacent. Why is this one adjacent?
Right next to each other.
Right next to each other. They're connected. Okay? How can I solve this? How can I find this missing angle? Right. I add what I know, and then what do they all add up to, Braylon? 360. Yep. So I get 326. So now I take that, 360 minus 326 to give me 34. So I have my two answers. Any questions on the front page? How many angle pair relationships are there?
8.
How many times are you going to use each one? Once. Okay. How many answers do I need on the front for each one? 2. Okay. Next page. 160. Oops. How many answers do I need on 9 and 10? 3. I need the missing angle. I need the classification of angles and sides. Okay, let's come over here for a second. If I want to classify by its angles, what are my options? Go for it. Acute, obtuse, and right. Acute angles. What does a triangle have to have in order to be acute? Less than 90. How many have to be less than 90? All 3. Okay, what about obtuse? Bigger than 90. How many have to be obtuse? Only 1. Okay, and what about right? What's a dead giveaway? The box, which the box means 90.
50.
Yep. About classification with sides. What are our options? Scalene, isosceles. What's the last one?
Equality.
Close.
Equilateral.
Equilateral. Okay, let's talk about these. What does it mean to be scalene?
It means none.
None are the same. What does it mean for isosceles?
2.
2 are the same. What about equilateral? All are the same.
Equilateral sounds like a shape.
Look at an example. Number 9, we want to find that missing angle. How can I find the missing angle? Add what we know, okay? 90 plus 70. What does that give me? 160. So how many angles does a triangle add up to? This is 180, remember? Triangles are 180. If you need to circle it, star it, highlight it, something. Okay, so how do I find that missing angle measure? Subtract from 180. 180 minus 160 is 20. There's one answer. How many more do I need? 2. So I need to classify by its angles next. Remember our angles, we have acute, obtuse, or right. Dead giveaway. Yep, dead giveaway. Remember, this, yes, we care about it, but when we get to the classification, we want to look at all 3 angles. Okay, so this one is right. Now, sides, are any of them the same? No, so what is it? Scalene. Good. Okay, when we get to 11 and 12, how does it change? It adds up to 360 instead of 180. So write it, circle it, highlight it, something. Okay? How many answers do I need on these? I only need 1. I only need to find that missing angle. How can I find a missing angle? Add them all up first. So I take 108 plus 72 plus 108. What does that give me? 288. Now what's my last step I need to do? 360 minus 288 is 72. Okay. Is number 12 similar? Yes. What do those boxes mean on number 12?
They're all 90.
They mean 90. Okay? Remember that. They all mean 90. Oh. Questions on 11 and 12. Okay. 13 and 14. What is it asking for? What are we trying to find? The interior angle sum. What does sum mean? Total. Okay? So, what equation am I going to use? N minus 2 times 180. Why did I put parentheses? Because that's what you have to do first. Okay? What does that N stand for? Number of sides. 13 has 4 sides. So I just plug it in, yes? So we take 4 minus 2 times 180. What do I do first? 4 minus 2 is 2 times 180, 360. Okay. How would number 14 change? The number of sides changes. What's 5? So instead of 4, I'm going to use 5. Okay? Questions on 13 and 14? All right, how does it change when we get to 15 and 16? It only wants one of them. So how do I go from the total to only one? But then I divide by the number of sides. You got it. So we're going to do the same equation we were using up above, but then we're going to divide by the original number of sides. So on 15, how many sides does it have? Again, so you don't make the mistake, put a tally mark after you counted each side. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so you don't make a silly little mistake. So we plug it in. 9 minus 2 times 180. What am I dividing by? 9. It's not going to be 7. We're dividing by 9. Okay, what do I do first? Yep, I do the whole top part first. So we have 7 times 180 divided by 9. What's 7 times 180? 1,260 divided by 9. What was your final answer? 140. How would it change when you get to 16? Just the number of sides changes, but you solve it the same exact way. Okay? Sides. On the third page. Why do you think I put 17 and 18 on there? So you know them, right? Use it as a word bank, okay? What are the 4 different types of transformations? What's one? Reflection. Rotation. Dilation. Dilation, translation. Good. Okay? Now 18, why do you think I put 18 on there? Right, to help you remember what happens to each one or what is going to happen to each shape. So, since I wrote reflection first, I'm going to describe reflection first. What's a word for reflection? Flip. Or if you put mirror, that's okay too. What about rotation? Turn. Dilation. Get bigger or smaller. I'm just going to put size. What's translation? Slide. Okay? So use those to help you on the rest of this. Okay? What directions tell you on 19 through 22? Right. Do you have to do any math at all? No, it just wants you to name which one's happening. Okay, on 19, which one is happening? Right, it is rotation. How can you tell? Because it's turning, right? It's turning. Okay, so it would be a rotation. Since I used rotation, am I going to use rotation again? No. What about number 20? What can help you understand that it's a reflection? You flip, and you can draw that line to help you see that it flipped. Okay, so that is a reflection. What about 21? Yep. Why is this one a translation? Right, it's the same exact shape, but all it did was move to somewhere else on the graph. It didn't turn, it didn't flip, or nothing. It stayed the same. Okay, and 22, that should be the easiest one. What is it? Why should dilations be easy?
It's literally getting
smaller or bigger.
Right, it's just getting smaller or bigger, and that's automatically a dilation. Okay, that's the only one where the size is changing. Okay, how many times am I going to use each one? Once. So if I have two that are reflection, can that happen? No. Okay, so use that to help you. Questions on that section? Okay, let's look at the next section. What do the directions tell you? Yep. Now we're actually performing the reflection or the dilation or whatever it's telling us, okay? Which one are we doing on 23? Reflection. What's the key word we used to help? What's the key word we wrote? Flipped. Okay? So, cross the y-axis. Where's the y-axis? Up and down, right? To help you, draw that line in so you can see it. Now, how do you perform a reflection? What helps? The number of spaces, the distance, okay? How far is V from our line of reflection? 1. How far should it be on the other side? 1. What do I label my new points? V prime. Same thing, W is 1, so it needs to be 1 on the other side. How far away is U? 3, so it needs to be 3 on the other side. Should it still be the same shape? Yes, but it just flipped over that line. Okay? 24, what does it want us to do? Rotate. When you see rotate, what are you going to do? First, you're going to figure out how much it wants. 180. Now, what am I going to do?
You just
Right, you're going to pick which one you're going to use over there. Since it tells me 180, which one am I going to use? I'm going to use the one that says 180, okay? You're going to write that formula down. What is it? Negative x, negative y. What do those negatives mean again? Opposite. Yep. So, what do I need to do next? Find the coordinates. What are the coordinates to D? Negative 1, 1. Now it wants the opposite of both of those. What's the opposite of negative 1? 1. What's the opposite of 1? Negative 1. And then go graph it. And again, what do you label them? Prime. What are the coordinates to E? Negative 3, 5. What's the opposite of negative 3? 3. What's the opposite of 5? Negative 5. Okay, last one, F. What are the coordinates to F? Negative 3, 1. What's the opposite of 3? Sorry, opposite of negative 3. 3. What's the opposite of 1? Negative 1. I got off on graphing a little bit. Okay, should it be the same shape? Yes, to help you, how many quadrants is it supposed to move if it's 180? 2. Did it move 2? Yes. Okay. Back, last page. Okay, we're still performing the transformation. What are we doing on 25? Dilation. What's going to happen? It's going to either get bigger or smaller. We need to determine if it's going to get bigger or smaller first. What is it? It's going to get smaller because, yep, if x is greater than 1, that's an enlargement. If x is less than 1, what is that? Reduction. So 25, enlargement or reduction? Reduction. Okay, so we know it's going to get smaller. What do we need to do next? Find the coordinates. Let's find all of them. So what are the coordinates to S? Yes. 1, negative 2. What are the coordinates to R? 2, 3. What are the coordinates to Q? -1, 1. What do I look for next? I'm either going to multiply or I can divide. What can I multiply by? 1/2. What can I divide by? 2. I'm going to pick divide by 2. Either way, it doesn't matter. Okay, if I pick divide by 2, what's 1 divided by 2? 0.5. Is it okay to get decimals? Yes. What's -2 divided by 2? -1. Yep. Still be careful of your positives and negatives. Okay. I'm going to divide each coordinate by 2. What's 2 divided by 2? 1. 3 divided by 2? 1.5. -1 divided by 2? -0.5. 1 divided by 2? 0.5. Now plot all of those. Should the shape change other than its size? No. And again, we said it was going to get smaller, so make sure that you are getting smaller. What transformation are we performing? Translation, so what's going to happen? It's going to slide. It's just going to move across the graph. So we have to read our vector they gave us, x minus 1. Which direction does x go? It goes left and right. If it's negative, I'm going to go left. So I'm going to go left 1. And then y is up and down. If it's positive 6, up 6. Why did I have you write that down? Right, because in words, this tells you exactly what to do. Okay, so from K, where am I going to go? Sorry, not K. I don't know where I got that from. B. Left 1, and then up 6. You're going to do that to each point. Left 1, up 6. Again, all that's happening is the shape is moving across the graph. Okay, some little notes for you to write down. X, if it's negative, it goes left. If it's positive, it goes right. And then Y, if it's negative, which direction does it go? Y goes down. If it's positive, it goes up. What are you doing? You're describing it, right? So first we need to start with which transformation's happening. Which transformation's happening on 27? Which transformation's happening on 27? Is it flipping? It is a translation. How do we describe a translation? How do we describe a translation?
You would have to put like x minus.
Right, we got to use the vector, right? So my original xy, I need to know how x moved. Which one's my original?
The one without the 1.
Which is left or right?
Right.
Right. And then that's my new one. I'm going to go from k. How many does k move, or which direction? Which direction do I move for k? Left. How many?
7? No.
6. So if I'm going left, is that negative or positive?
Negative.
Yep, so x minus 6. And then how many am I going up or down? 2. How do I write that? Y minus 2. So for translations, that's how you describe it. Okay? Since I used translation, do you think I can use it again? No. Okay? 28, what's happening?
Rotating.
It is a rotation. Okay? Which one's my original?
The one that's on the bottom.
Bottom. Okay? What do we need to figure out with rotations?
Then how many?
Which way and how many degrees? How many quadrants did it move? 1, so that's 90 degrees. Now, clockwise or counterclockwise? I'm going this way. It is counterclockwise. So, since I used rotation, can I use it again? No. If I got a 180, how many quadrants would it move? 2. Would I need clockwise or counterclockwise? No. All right, 29. Which transformation's happening? Reflection. How do I write the rule for reflection? Yep, whatever line it's going across. Here's my line. How can I name that line? It is x equals -2. Why is it x and not y? Which axis is it going through? The x, so that's why it's x. It's going through the point x equals -2. Okay? If I had one like this, how would I write that equation? Y equals 3, because it's going through the point y equals 3. Okay? All right, last one, 30. Automatic what? Dilation. Good. So what do we have to figure out next?
How much
Does it enlarge or does it reduce? Which one's the original?
The one that's small.
The small one. So if I go from small to big, that's an enlargement. What do I need still? By how much? So enlargement by, we need to figure that out. What's the formula I gave you? New divided by old. So does it matter which coordinate you choose? No. Which one do we want? U, V. Which one do I want to find first? The new. If I find the new, what are my new V coordinates? 2, 0. Now I want to find the old V. 1, 0. What's my last thing that I have to do? Divide. Does it help if I do 0 divided by 0? No. So I need to do 2 divided by 1, which is 2. So we had an enlargement by 2. Okay? Questions? 1 to 5 on transformation.